Hello, hi. In this video, I will be explaining the machine learning system design of Alibaba recommendation engine. So, as we all know, Alibaba is e-commerce giant of the world with the 250k employees and $200 billion of market cap. So, the researchers at Alibaba, they proposed a novel architecture which also takes the sequence of items into consideration while recommending the new products. For an example, a user who bought an iPhone is going to buy uh, a charger and or mobile cover in the coming days. So these kind of things, these kind of recommendations and the feature interactions were ignored by the earlier recommendation system. They were not taking this sequential natures of recommendation into consideration. So Alibaba was the first one to propose like transformers to perform the attention mechanism. So to understand this paper better, we will have to go through the other papers, like one from YouTube and the second from Google Play Store. So which explains the recommendation system of a YouTube. So nowadays, like deep neural networks are being used for both candidate generation and the ranking. Like to explain it better, like YouTube has billions of videos, and those billions of the features of those billions of videos are embedded and fed into candidate generation deep learning model. And after feeding them into this deep neural network, like the top candidates are generated, like top n, like top 100 or top 1000 candidates are generated, and these top 100 candidates are then fed into ranking deep learning model, which is like for optimizing the CTR, and like it gives like the probability, like which videos like user will watch or not. So so let's explain the high level architecture of candidate generation model. So this is a candidate generation model. So it embeds all the video watches of the user and the search token with some geographical and age features. So they are concatenated and they are finally fed into deep neural network, and the on top of that a softmax is trained. And as we know, softmax gives a matrix, like it gives a matrix representation of all the class labels, and it gives a probability. And this matrix is used to generate the like n-dimensional embedding, and we finally embed these all the videos, and like all these videos and the features into n-dimensional embedding. And whenever the user gives a query and we perform an approximate nearest neighbor search, as we know, in n-dimensional embedding, the nearest neighbor is going to be like order of n d square, order of yeah, n d square. So it's going to be like too complex. So for like some it's gonna have like too much time complex process. So approximate nearest neighbor is performed, and which uses like optimizations like KD tree and locality sensitive hashing to reduce the inference time. And this is a ranking model, and all the top n videos which are outputted by the candidate generation model are fed into this, and videos are fed into this. So this model, and as you can see, these are the concatenated embeddings after feeding into this. So top n videos are outputted and they are sorted by probabilistic score. For example, the video of Virat Kohli is going to have the probability score of 0.9 and MS Dhoni is going to have the probability of score of 0.8. So that the with the video with more probabilistic score will be recommended to the user, and they are going to be in the feed rankings on the top. And I'm ignoring the positional bias and also exploration and exploitation for the simplicity. Now I'm going to explain wide and deep neural network, which was used for ranking in Google Play Store. Eh, so let's begin. So this was the wide and deep neural network. As you can see, like wide and deep neural network, like take like this model is learning the feature combinations, like when the uh, feature engineered features are fed into this wide model, and it learns the feature combinations and the best feature combinations. And and whereas the deep neural network, so deep neural network is it learns from the raw data best, and it generates the new feature and learns the new feature combinations from the raw data. So whereas the best of the both world is wide and deep neural network. So this wide and deep neural model performs both memorization and generalization. Like memorization is like learning the best feature combination. So memorization is learning the best feature combination, whereas generalization is learning from the raw data, the from the raw unseen data. So this performs both memorization and also generalization. So this was done in a ranking stage of the Google Play Store, and and there was considerable increase in app acquisitions and increase in CTR, etc., etc. Like this was like the taking the best of the both worlds transformer in Alibaba recommendation system. As I am reiterating that the user behavior are sequential in nature. For example, on the day one, the customer is buying a mobile phone. Next day, he is going to buy a mobile charger and a mobile cover, on and so on. So to capturing this feature interaction is like a little bit complex. So the first architecture that came onto our mind is LSTM based architecture, which with the attention mechanism, with the bidirectional attention mechanism that mimics the attention mechanism. So but as we know, like training LSTM is like little bit complex, and that are not sequential in nature. Like no doubt LSTMs are lightweight than the transformers, but training the LSTMs is sequential process, and for that like that's not easily parallelizable like training the transformers. Like we can like transformers can be easily trained because they are just matrix operation which GPUs can easily handle, and also they are not sequential like LSTM based approaches. So let's then dive into the paper again. So as I was saying that the user buying behavior is a sequential nature, and to capture this relationship, so I was saying that user buying behavior is a sequential in nature. To capture this is capturing this is gonna be little complex. So for to like overcome all the challenges with LSTM, a transformer based self attention layer was incorporated. So as you can see that all the features related to all the features like item ID and category ID, they are separated out and they are positionally encoded. These blue vectors are positional encoding vectors, and finally they are concatenated, and they are just fed into transformer layer, whereas the other features, they all vectors are concatenated and they are fed separately. So why only category ID features and the product item ID features are separated out? First of all, like if we just take all this feature and with this we incorporate all this feature over here, then that, as you know, transformers have like quadratic time complexity. So and the quadratic time complexity is gonna affect in our like inference time and also training time. So it was like it was better to remove keep these features separate. So obviously the model performance was going to be increased, but it was better. So these uh, these sequence item features are positionally encoded, so and they are fed into transformer layer. For example, that our target item is mobile cover. Yeah, mobile cover. And this is and this embedding will be generated such that it will give more importance to the mobile phone, like because the purchase of mobile cover is directly dependent on mobile phone. So this embedding, the attention mechanism will embed such that it it gives more importance to mobile phone and as per the query. Now moving further, mm, yeah, this is a positional encoding vector, and this is a TVT represents the recommending time, and VI represent the time stamp, and this represents the time recommending time, and this represents the time stamp, and this is a, like our positional encoding vector. So which like this blue one is all the theory behind the self attention, and the other one, and this is a attention mechanism. And this is a and the attention mechanism, we are using a scale dot product attention, because like if scale dot product attention is like is was better than the normal attention mechanism, because we are normalizing our values. So and there is like similarity between key and query. Parameter matrix is computed and they are scaled down, and finally the softmax is computed on top of that, which gives like the values between 0 and 1, and finally it's multiplied with the value vector. And this is a self attention multi-head self attention mechanism. And and as you can see, there are multiple heads which are concatenated. And yeah, these multiple heads are concatenated and normalized. And if our attention mechanism is not giving like it's not optimizing or converging, the skip connection is there. And after that, there is a feed forward neural network, and feed forward neural network is there too, because we are having a high dimensional vector. Yeah, it's like probably 256 to or 512 dimension vector. So like, and it's not it's and converging this to this vector will be like converging this to a optimal local optima, or global optima will be like it's gonna not be a convex optimization, it's gonna be a non-convex optimization. So to capture this non-linearity, feed forward neural network is there. And after that, if the feed forward neural network is not helping in optimization, then there is a skip connection, and skip connections are like common in electronics field. And these all is explained, all the things I explained is theorized over here. And finally, the loss function. As we know, the loss function is binary cross entropy, which we also call the log loss. And it's, as you can see, the researchers at Alibaba chose wide and deep neural network as a baseline, which produce 0.7734 of AUC. in offline as a offline metric, but after like some modifications in wide and deep neural network of having some sequential encoding, and also training a new deep information network which improves on item interactions, there was like 4% increase in CTR, and with the minimal increase in latency. So this was considerable, like even 1 to 2% increase in CTR is really significant in this online billion scale system. So but behavior sequence transformer outperformed all of them, and behavior sequence transformer produced 0.7894 of AUC, which was like best, and increased CTR in behavior sequence transformer, which is really significant. And yeah, this 1 to 2% increase in CTR is really significant, and it brings in millions of dollars as a revenue. But there was also 4 milliseconds increase in serving latency, which is like optimal, like they can do some improved techniques like caching and also some other things. This can be overcome. Also, like there is 4 milliseconds. To conclude, what I can say is behavior sequence transformer is able to capture the sequential relationship of the items better than all our previous models. So thank you, thanks for watching.